And the reason is because an angle in a semicircle is a right angle. Let's prove it. So if I get a right angle at the top, I know from the ends I've got a semicircle. So I know I'm drawing the diameter.
We did this with vectors last year.
Correct. So you should have known why. Now be careful you two, Travis and Eddie. This year, on the end of year exam, if they ask you to prove that the angle in a semicircle is a right angle, technically, if they don't tell you not to use a vector method, it's probably okay, but they're looking for the non-vector proof.
Alright.
Okay? Be careful. You guys, next year when you do this with vectors, they'll be looking for the vector proof. Okay, so the angle in a semicircle is a right angle. If I draw a semicircle and I draw, notice I'm deliberately drawing it slightly off the centre. Okay, it's quite a bit off the centre. That's very deliberate. I don't want it to look like 45 degrees. I don't want my brain to trick me into believing that these two are equal or anything like that. Specifically draw it off centre, which they don't do in the textbook, but it's important. All of these proofs, you want to try to avoid making assumptions that aren't true. So deliberately skew it to make sure you don't make that assumption. We're going to have the centre, because I know it's a semicircle, A, B, C. And I want to prove that the angle at B must be 90 degrees. Any ideas before you look at the textbook?
OA equals OC, magnitude-wise.
Good. So this length is the same as that length, correct? Not helpful in this case. We definitely needed that for the vector proof, but not for this one. For this one, I'm going to draw in this extra line. And then, hopefully a few of you are good at writing small, I'm going to label these angles. X and X. How do I know they are equal? How do I know for sure they must be equal? Someone other than Eddie and Ryan. Shannon, why do you think they must be equal?
Which one, sorry?
The two angles I've labelled, how do I know they must be the same?
I'm not sure.
So I guess indirectly, Eddie, we do still need these to be equal, because these are both radii. You agree, Shannon?
Yep.
Well, that means this is an isosceles triangle, which means the two base angles must be equal. Let's do the same on this one, y and y. Consider triangle ABC. The angles in this triangle must add up to 180 because it's a triangle. That means x plus y plus y must equal 180 degrees. Do you agree with that statement? That means 2x plus 2y must equal 180. Now divide everything by 2. X plus y must equal 90 degrees.
So we don't even have to do the other ones.
It's done. Wait a minute. X plus y is the angle I was interested in. Therefore, angle ABC must be 90 degrees. And we have proven that an angle in a semicircle has to be a right angle.